This conference will now be recorded.
Hi dear SQL folks, let's next talk about on the hash match join. Okay, this is the costliest operator in SQL Server. So the previous classes we have discussed, right? Like table scan, clustered index scan, hmm? So index seek, and sort operation, key lookup, row ID lookup. huh? So these are all we discussed and how to avoid them. That and all we discussed. Okay, now let's focus on the hash match join. So how we gonna avoid this? Okay, to make the query better, to give better performance. So how to change? So is there any options to change? And all? Let's discuss. Okay, so before discussing about a hash match join, we need to discuss about the types of joins in the SQL Server. Okay, the types of joins means it's not like inner join, left outer join, right outer join, full outer join. I'm not talking about those. Okay, so whatever the join here, inner join, left outer join, right outer join, whatever the join here, SQL Server engine in the background, uh, it uses these three joins. Okay, one is nested loop join, merge join, and a hash join. These are all three types of joins SQL Server engine it uses to compare the data between or among the tables. Okay, so uh, these three approaches it will follow. Okay, so when SQL Server engine follows the nested loop join is when two tables are, see here. So I have joined these two tables and getting this data. Okay, so here I am using inner join. Okay, so it is joining of these two tables, getting the data. But when you are joining team here, maybe you can see inner join, merge join, and hash join also. Huh? So SQL Server engine it decides it. Okay, see here a hash match join, right? See this hash match join can be um, let's convert into. I mean, we are not converting SQL Server engine based on the data and its values. It automatically it uses that algorithm. Okay, so here has why hash match here, why hash join here it is using is because these two tables are very big and it is processing very large two data sets. That's why internally it is using hash match. Okay, so suppose if I use where class some data, okay, suppose some salesperson ID so and so. So let's take some example. Let's take like salesperson 290. Let's use that. Okay, let's see this hash match join can be converted into nested loop. Uh, Either you can see estimated execution plan or actual execution plan. Let's run with the actual execution plan. See if you see here, see nested loops. Okay, so team, nested loop can be used on the small data sets or indexed columns. Team. Okay, hash join means when there is a huge data need to be compared and get the data. It takes a lot of time if you go with nested loops. Okay, so nested loops means team. Okay, so let me take some example. See, there is a table A containing these data 46, 0, 18, 148, 10, and another table like 10, 11, 0. Suppose if we have the data like this, nested loops, how it will run in the background? When the written data is very less, uh, small set of data team, in such case what will happen, it will use the nested loops. How nested loops in the background will run? Just 46 can compare with 10. If it matches, okay, it won't return. If it is matching, then it will return. See, like this 46 can be compared with the 10, next 11, next 0, next. Once it is over all the rows, next go to the 0. 0 can be compared 10. See, like this. Okay, nested loops can run in the background team. This is best. This is best for when two tables are, uh, when two tables are small data set or indexed columns. Okay, so if we have really indexed him, definitely it will use in nested loops. Even though if you have a index team, when there is a huge data, then definitely it will use the hash join only. Okay, so I will show you the exact these three differences team. So let's learn all these three. These are all very important team in the performance tuning improvement for the SQL Server queries. Okay, so here memory usage is very less because at a time it will sort it out and it will run it and it will go to the next. It won't need to dump everything into the memory because it's a small set data sets. Okay, so see, next join, about merge join, let's discuss this merge join. It's a intermediate tables you can use. I mean, it will be used in the background. Intermediate, like a kind of smaller or like a big, not that much very large, medium type tables. Merge join is good. So merge join, how it will compare. See here in the nested loops, each value is comparing with all the values in another table. See, more comparison is happening in the nested loops. Suppose here 10 rows, here 30 rows, 20 into 30, 600 times loop, 600 times can be compared. So n into n number of. See how to, if it is a small, that's fine. If it's small number of rows, that's fine. So when it is a very like medium size, it's not a good even nested loops. So medium size, it will use the merge join. In the merge join team, when can it can be used is when the data is in sorted order. Can you see here? Suppose 1, 6, 10, 11, 12, 14, like this. See, it's a sorting order. In relation B also, it's in already in sorting order. If it is not sorted already, it will sort. It will take the data into the memory and it will sort it out and it will compare. See here. So one need to compare with the other data. So here, so in the merge join, like uh, here number of loops should be less comparatively nested loops. See, one can be compared with here, right? 3. So not match. One cannot go with 12T. Why? Because it's already in sorting, right? When cannot one cannot be find here at the 3, definitely it cannot be found in the next values because it's already in sorting. See, that's how the number of comparisons will be reduced if it is sorted. Okay, see here 6 can be compared with the 3. It's not there. Next 6 can be compared with the 12. Oh, 12. So next no need to compare it. So that's how the merge join will work. See here, number of matches and all will be reduced. Huh? See, in a column in the first table there is a indexed order structure. Column B secondary, there is a structure too. As a result, a merge join will work very well because both of the columns to be joined are in ordered structure. Merge join compares two columns in a join with the two columns and it is equal, it returns the result. So that's how the merge join will work in the real time. So merge join will depend on the sorted data. So and see here, if you don't have the sorted already, the data not sorted, again sorting it takes time. So that's how the SQL Server engine, it checks if it is already sorted at all. It may go and use the merge join team in real time. Okay, so that's how the merge join. So these are all three ways SQL Server engine to choose to compare the data team. So which one will use and all, again, like so best for small tables, best for medium tables, and has join for very large tables. See team. So even like very big tables, nested loops also, even medium tables doesn't good for nested loops because it has to compare like n into n, right? Even merge join also. So sorting for the very big table, again it's very difficult. Sorting on very large million rows table, it's really difficult. Not million, even like unsorted data uh, of the tables, like using merge join nested loops, it's a costliest operations. So in the hash join team, when you are retrieving very like huge data or processing very large data, hash join will be used team. So this is the best example here. Okay, so if I don't use where class, definitely this will become the here hash match join. Okay, so can you see here? So all the rows, almost 461 rows are there. Sorry. Uh, 31,465 rows are there. And here, how many rows are there? So 1,009, sorry, 19,900 rows are there. These two are processing. Hash match is happening, and it is getting the data of how many rows team. So almost number of 3,806 rows it is returning total. Okay, so see that's the hash match because very large number of rows. Okay, so team, suppose say by default it is using hash match join here. So can we force this query to use nested loops? Let me try it. Let's press Ctrl R. So see, I want the same result. Okay, I want the same result. So by default, this is a hash join, right? Hash match join. So let's force this one into a nested join. Okay, so nested join. So in SQL Server, we don't have a nested command team. Okay, we have a merge command team, but we don't have a nested one. So same like here, you can use hash join. You can force SQL Server to use that join and all. So another one is default one. Okay. So here, if you don't mention SQL Server, it will decide which one and all. Nested loop, merge join, or hash join. So this is going to hash join by default because large data sets because two tables. Okay. So let me use these three and let's see like which one the performance wise which one is better and all. Let's see which one is better team. You can guess it easily. Like so the best one is whatever SQL Server engine decides that one is the better. See, SQL Server engine also sometimes it takes wrongly because of what? Because stats wrong. If you haven't done stats regularly, if you are not doing rebuild, reorganize, update stats regularly, so SQL Server sometimes also it may choose in the wrong join. Okay, so those are all very important tip. So maintenance is index maintenance and all is very important. Stats maintenance is also very important so that the SQL Server it will choose the best join always. Okay, so team here we don't have a nested loop join I cannot use, right? So there is another way to alternative. You can use this option loop join. So this hint. Okay, so this hint will force the SQL Server engine to choose the nested loops. Okay, just three I am choosing. So either you can choose the estimated execution plan. So the result is same thing. The result 3,806 rows only will show all these three. Huh? All these three queries, it will show the same set of rows only. Okay, so team, let's see the estimated execution plan for these three. See, can you see here? 45%, 34%, and 21%. Among these three, okay, let's maximize this here. So the first one is nested loops. Okay, the problem here nested loops is like it's first of all these are all not a it's not returning a small data, right? So definitely it takes see it consumes a lot of resources. 45% it is happening. Okay, next can you see uh, uh, merge join? Okay, so merge join we are forcing to use. See merge join. uh, so here has joy. Okay, so which one is less? 21% is less. Okay, so 1 second.
This conference will now be recorded.
Yeah, so I'm back. So team, if you see here, okay, so the best one here is for this query, the has join. Okay, see here directly it is using index scan. See, non-clustered index scan is happening. The other one, clustered index scan. Okay, so if you see other merge joins, see this merge joins both the places clustered as scan only, clustered index scan only. That means, see for this person table, like here clustered index is nothing but a entire table. Okay, for getting the data, so getting the all the rows and it is scanning it. And see the problem with this merge join, I told you, right? It required sorting. Okay, it requires sorting. See the sort operation happening. Because the data it's not sorted, uh, existing data, so internally sorting is happening. Hmm? See the more cost team, when there is a more cost, obviously parallelism it required. It uses the parallelism, the more cost. See the streams, the arrow marks, can you see here? It's using parallelism. Okay, it's like merge join is not a good here. Hmm? For this query, I'm not saying merge join at all not good. Okay, it all depend on the data and data sets. Yeah, so here see the other one merge join is not good because see sort and all, oh my god, it's 34%. So it's just 21% only. The next, this is a really worst here, nested loops comparatively merge join and has join. See what's happening here, like both the places cluster index on seek or scanning is happening, like old table it is using. And how many rows in this uh, table, and here how many rows in the table, that many rows loops, n into n number of loops are happening. See here, that many loops are happening, and getting the data. So again parallelism, because that many, right? So the cost is more. So so this how the SQL Server engine it picks the best one in the background routine. Okay, so I cannot show you the exact like which query it uses and all. So see, I showed you right before, like when you use the where class, something here. If you choose in the where class, definitely that is the best one. Mm. So let's use this salesperson ID 290. Which one it shows the best? Okay, so I'm forcing here to salesperson ID, and here salesperson ID, salesperson ID, and this is a default. So default team. So see, I'm not using any hash join, merge join, and all here. Like by default, what it takes SQL engine, definitely nested loops. Okay, so nested loops is good for this one. See nested loops. Okay, so let's run with this value, like which join will use, which it will pick up, which one is good and all. Okay, so let me run with estimated. Hmm? So here which one is the best? Okay, obviously nested loops 33% only. See nested loops and merge join almost same uh, cost, query cost it is showing. Okay, but internally like CPU memory consumption and all, definitely nested loops is better. Like if you want, you can use set uh, IO on, set CPU on. If you see like CPU, logical reads, physical reads, okay, and compile time, execution time. So those are all comparatively merge and nested loops is less. Okay, in this scenario, for this query I am talking. Okay, so see like this internally SQL Server it will decide which join will be used and all in the background. Okay, so again team, so we do not have control on the joins team, like which one will be chosen and all. We don't need to mention anything, that and all will be taken care by SQL engine. Okay, so suppose let me tell you a scenario. Suppose your stats and all bad, but still SQL Server if stats and all bad team, like definitely it use the wrong join. If it is using the wrong join team, like you can force the SQL Server engine to use the right join. So such scenario, you can mention the which join need to be used to SQL engine and all team. So currently I'm like in our environment, I'm handling 40 terabyte database team. Like we don't do that much frequently, like rebuild, reorganize, update stats. So that's why uh, uh, we instruct the SQL Server engine to use the joins. Okay, so such kind of environments you can go and you can use these joins team. Like when you are really doing rebuild, reorganize, update stats very regularly, don't mention this kind of external joins and all in these keywords. Okay, so don't use these table hints and all. So let's take it up to SQL engine. When you do not do any regular rebuild, reorganize, updates as, and those are all really bad in your environment, go and mention according to this. Okay, if it is very large, just mention has join. You can also compare him, like before taking a decision, why can't you try like this? You don't need to run. Without running those, you can just check the estimated execution plan and force SQL Server engine to choose that one. Okay, yeah, thank you, Tim. Thanks for watching this video. uh, so if you like this video, subscribe my YouTube channel, team, so that it is possible for me to make more videos. And also please comment in the comment section, like whatever the content you want, so that I can make a video on that. Thank you, team. Thanks for watching. Have a nice day.